Okay, welcome back. Here we go on the first trigonometry chapter. If you're sitting there at home, say it out loud. Y'all say it too. Repeat after me. I'm a genius.
I'm a genius.
And I apply my wisdom. Yeah, so there's 6 trig functions. Okay? That's why they're fun. Cracking me up right there. So we got 6 of them. You saw 3 of these last year in geometry. And more than likely, whoever taught you in geometry taught you Sohcahtoa. Now they may have mispronounced it and said Sohcahtoa or whatever. So that's one of only 3 Japanese words I know. I know Sohcahtoa and Toyota and Godzilla. That's it. The only 3 Japanese words I can say. Of course, Miss Jones, who I used to school with, is an old hippie. So the way she remembered this was, some old hippie caught another hippie tripping on acid. So that was always funny right there. You can remember it that way if you want to. So we're going to write it, every problem, I want you to write Sohcahtoa like that. Okay, up and down. This one, of course, is sine. We're going to use this Greek letter theta for a lot of the angles. So I've got sine of theta. And this is the side opposite over the hypotenuse. Sine, everybody repeat after me, sine, opposite, louder, hypotenuse. Yeah, y'all aren't going to get on YouTube like that. Try it again, sine, opposite, hypotenuse. Okay, so yippee skippy. So we've got sine, opposite, hypotenuse. The official spelling has an E on it. They've just shortened it. We don't say sin, please. It'll remind somebody being in church and feeling all guilty, so you wouldn't want that to happen. So everybody say sine. I rest my case, and let's come down here to example 1. So in example 1, let's say I had any old right triangle, and the sides were like this. There's some Pythagorean triples where all the sides will be whole numbers, not all of them, but some of them. So right over here by this one, abbreviate opposite and put theta right there. Because the side opposite from theta is as far away as you can get from it. It also, the side opposite of theta does not hit the vertex down here. It's not that side and it's not that side. So it's as far away as you can get. The one across from the right angle is always the hypotenuse. This other one is also the adjacent. Please label these all 3 on every problem. Okay, then if you need to ask which side's the opposite, I'll be glad to tell you, but we expect you to be able to figure that out. Go as far away from this angle as you possibly can go. Okay, and then come right here and write sine, opposite hypotenuse. And we just want to make a fraction. Let's see, the opposite is 5 and the hypotenuse is 13. Ding, 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 ding. We're done. That's all you have to do, is make a fraction. Does the fraction reduce? Not this one, some of them will. And there's the sign. Okay, so let's go back up here to ca. That's for cosine. And this is the side adjacent over the hypotenuse. Side adjacent over the hypotenuse. We're going to make a fraction, but we're going to use 2 different sides. Well, the hypotenuse will be the same, I guess. So come right here and write ca, then write cosine, And then we've already got the adjacent label, and I've already got the hypotenuse label. Ding, 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 we're done with that one. That's really not, those two are really easy. Actually, there's three things we'll do in this first section we're working on right now, and this is one of them. It's called write the 6 trig functions. And then this one is tangent. We abbreviate it tan to make you think of being out in the sun. And that side opposite over side adjacent. So now we don't use the hypotenuse on tangent at all. And let's come down here and write TOA, tan, opposite, adjacent. We're done. So there's the first 3 trig functions. Now you'll probably notice I said there was 6, but we've only done 3. So we got to figure out what the other 3 are. The chances are pretty good they didn't show you these other 3 in geometry. Now if they did, okay, then you'll be ahead. Okay, so these other 3 are called reciprocal functions. The first one is called cosecant. C-O-S-E-C-A-N-T. It's abbreviated CSC of theta. Is just the opposite of sine, or the reciprocal of sine. So this one's hypotenuse over opposite. Repeat after me. Flip the sign. Say it again. Flip the sign. Louder. Flip the sign.
Flip the sign.
Okay, so come down here and write CSC. Flip the sign. These other 3 will be real easy to find. You just take right next door to sine, just put cosecant, CSC, and take this sign and just flip the fraction. And you'll have it. There's that one. This next one is just secant, abbreviated SEC. Flip adjacent over hypotenuse to hypotenuse over adjacent. Go down here, write SEC. By the way, that's not the Securities and Exchange Commission, just in case you were wondering. Flip the cosine. So really we'll find 3 of these and then we'll flip them over. And then this last one is called cotangent. Spelt like a cot, which makes me tired. Adjacent, that's a place to sleep. Over opposite. Come down here, abbreviate cotangent, 12 over 5. Ding. We're done. That's the first example of finding the first problem with the 6 trig functions, and we'll be back.